Okay, so let's start the contents for the Eurocode design in Midas Gen. So this is the general introduction of Midas Gen. I'm not going into details of this, but for the design feature, what do we have? What Midas Gen provides? We provide the design mainly for the steel and the concrete. So we have the steel design for the based on the specified design code, we can verify whether the section is safe or not in terms of the ultimate limit state as well as the service limit state. And also the optimal section design is provided. I will also show you this feature as well. So optimize the section size. The smallest weight of the section can be found with the program. For the RC design, we provide frame design like the beam, column, and also wall design is there, and also the slab design or mat foundation design using the 2D elements. So 1D elements and 2D elements can be designed. I mean, it can be verified based on these design codes, and also you can check whether the section is safe or not. I think the capacity design is not the major issue for you, but just for your information, the capacity design as per the Eurocode 8 is also there. So non-seismic zone and seismic zone, both we provide the design feature. And for the footing design, especially for the Eurocodes, footing design is available in the additional module, which is called Design Plus. So I will show you the footing design function using that Design Plus function. And this table shows the available design code. So at the end of the session, I will send you all these slides so you can check it later, more details. Basically, we provide the design standard for the American, European, and the British standards, India, Canadian, and some of the national European standard like the Italian standards, and China, Japan, Taiwan, Korean. So these are the codes we have. It's similar for the RC, steel, and in case of the SRC, this is stands for the steel reinforced concrete design, like the infield column or the composite member. So SRC member, at the moment, we do not provide the uh, European standards, but composite beam and column will be available in the first half of next year using the Design Plus module. At the moment, in the Design Plus, we provide the strip footing, patch wall, like the combined wall, and the irregular column checking. And in the January, we are going to release the new version. In that version, isolated footing and the bolt joints for the steel structure will be provided as per the Eurocode. And the other version, the future version, which will be the May release, as you can see, these two features will be there. So Eurocodes, in the Design Plus, we are keep developing the additional modules. Gen stands mainly for the major member design, like the RC frame and steel frame and the main walls, structural walls, and the slab. But for the additional parts, like the footing or the base plate or joint, we provide those design features using the Design Plus additional tool. The data can be exchanged each other. So we perform the global analysis from Gen, and then we bring the member force from Gen to Design Plus for those unit member design. So we are going to check with the program how it works. For the timber design, at the moment, Midas Gen or Design Plus do not support. And at the moment, I'm sorry, but we do not have plan for now. So timber design is not there in Gen or Design Plus. Additionally, for if we check a little more details for the Eurocode, so we have all the database for the material section loading, and I think you already know we implemented the Sweden Natural Annex for the auto generation of the load combination and also the design features. Also, if you are dealing with the seismic analysis like the pushover, we provide the Eurocode pushover analysis feature as well. So let's see more details for the design feature, starting from the RC frame and wall design. RC design, if you go to the program, so before we perform the design, there are a few steps we should define in advance. First of all, we have to define the load combination. If you are dealing with the concrete design, you move to concrete design tab. If you are dealing with steel design, same, you go to steel design tab. And then there is the function auto generation. And here you can see also the Sweden National Annex. So we can automatically generate the combination. Or if you want, you can also modify or you can directly enter your own combination by yourself. For the repeated work, this table format is there, so you can use the Excel table and then simply copy and paste for entering the repeated combination. After generating this combination, now we want to perform RC design. So as you can see, ultimate limit state and then serviceability limit state both are provided in Gen, so both combination are there. If we use this auto generation function, serviceability combination type will be also automatically detected. So if we go to serviceability load combination type here, so coarse permanent, frequent, or characteristic combination can be automatically classified here. If you manually enter the combination by yourself from here, in that case, program cannot know what is the characteristic or what is the coarse permanent combination. In that case, you can manually bring certain load combination like this. And before performing the member design, there are several options which will be used for some auto calculation like the effective length factor or the moment magnification for the design. So in order to correctly design the member, we need to know why those functions are there. So important design parameter I have mentioned here. So I want to briefly explain you what do we provide and what do you need to select. For the moment magnification, we need to define whether our structure is a sway structure or non-sway structure. So that can be classified here. And also effective length factor can be automatically calculated by the program once we check on this option. But if you want to enter your own effective length factor, then you can also enter your own factor. So this will be used for checking the slenderness ratio. And sometimes, let's say this is the top view of our frame, and member is shown like this, the main girder. Because of the sub-beam, in order to consider the connectivity between the main girder and sub-beam, we have to divide this main girder. But if you want to design this main girder, you do not want to design it as the three different member. You want to just consider it as one member. In that case, we need this function, member assignment. So if you go here, member assignment, we can see the two options, manual or automatic. So we can, let's say, if I want to, this is not the common case, just for your information. If I want to design these two members as one In that case, I can just select them and click apply. Then that will be considered as one member. Or using the automatic function, and if there is sub-beams, in that case also, program can automatically detect the nodes which is dividing one member without the vertical element. Those can be detected and entered in the program. So these member assignments can be useful when you have the several sub-beams in your model. And unbraced length can also be detected by the program, or you can modify if required. And this unbraced length will be also used for the slenderness ratio calculation. Unbraced length, so for example, for this column, for this A and B column, unbraced length for the Y direction and Z direction should be differently considered. Y direction, we should consider the unbraced length for A and B separately, but for this Y direction, unbraced length should be this L1, which is the summations. Those can be considered by the program, or you can also modify that. Those unbraced function can also be found in here. If it is not entered, program will detect. Or if you want to modify, you can directly enter the certain length and select your desired member. Also for the laterally unbraced length, we can specify it here. Or if you do not consider it, in that case, just the same value as the unbraced length YZ will be used for the laterally unbraced length. And this is the function for considering the rigid zone. In the model file, for example, for this overlapped parts, for doing the design, if you want to consider the member force not from the end of the section, but in this column face, in that case, we can use the two different functions in Gen. One is P-band offset, the other one is Penrose effect. So any of them you can use. So if Penrose effect is used, program can detect the section size, and then the member force in the face can be used. Or we can directly enter the size, the dimension of each of the direction. So this P-band offset function can also be used. So if we want to take the member force, excluding the rigid zone for the beam and column joint, in the case, we can use any of the function here. And which shape of the section can be designed in Gen? As you can see from this picture, in case of the beam, we can design rectangular or T-shape. In case of the column, we can design solid box or solid round or the hollow circular section. For the wall, we can design this straight wall only in Midas Gen. I mentioned Design Plus also provides the wall design function. So in case of the straight wall, we can do the design in Midas Gen using the wall element. But if you need to consider the combined wall, like the core wall, which has the not the straight shape, in that case, we can use the Design Plus option that I'm going to show you also. And this is the load combination I already mentioned. In this load combination, when you consider the static seismic loads or response spectrum loads, you need to consider the orthogonal effect for the both direction of the archaic loading as per the Eurocode. So this 130 rule can be considered using this option in the load combination. And before performing the design, also serviceability parameter can be entered. In the serviceability limit state checking, we provide the stress and the crack and deflection checking. For that, in order to calculate the allowable stress or the allowable deflection and also the crack width, this parameter, this value can be entered from here, and then they will be used for calculating the allowable value. And short-term and long-term loading can be classified here. It is required because when we are calculating the stress, allowable stress, the long-term allowable stress and short-term allowable stress needs to be classified as per the Eurocode. Because of that, if you see the serviceability loading, short-term and long-term, we can classify what is long-term and what is short-term loading. Based on this classification, then the program will calculate the allowable stress for the short-term and long-term. And for the partial factor and roots and the design parameters, so we specify the design code from here. You can see all the implemented code. Among them, we are going to use the Eurocode latest one, and we select the natural NX. If you want to consider the capacity design, you can check on this. Otherwise, I will not check this. And for considering the slenderness limit for the moment magnification, as per the Eurocode, we can consider these factors. Or if instead of using this, you can also perform the p delta analysis. So second order moments can be automatically considered. So there are two ways for the moment magnification. One is considering the p delta analysis here, or if you do not perform the p delta analysis, in the case we can consider the moment magnification using this slenderness limit ratio. As this formula and all this factor is based on the Eurocode, as you know. And partial factor. Partial factor is automatically entered based on the Swedish national annex. But if you need to enter any other value for the overseas projects or just for the test purpose, like the entering all the factor as one, in the case you can also modify from here. And before most of the important design parameter I already explained. And for the member design, member checking, we can select the desired reinforcement, which lever will be used for my automatic design. That can be selected from this design criteria for the beam elements, column, or the shear wall. As you can see, only one part is activated at the moment. If you want to change this into the PS or EN, we can go to Tool, Preference. So we can, if we change the lever to the desired standard, for example, Eurocode. In the case, it will be changes to the Eurocode. And now we want to perform design. So design can be done from here, concrete code design, but right below you can see also very similar function, concrete code check. So I want to explain the difference between two. Concrete code design stands for giving you the basic idea, the initial idea, which reinforcements the program think required. So based on the options you specified from here, like which lever will be used for the main lever or the strap, using this, program will show you how many reinforcements is required and what is the spacing for them. For example, for the beam design, just the program automatically calculate the required reinforcement and the spacing, like the main lever and the strap. After that, considering the constructibility or based on your experience, you may want to enter the reinforcement by yourself, and then you just want to verify whether your input is safe or not as per the Eurocode. In that case, you can use concrete code check. So in this case, let's say I enter the reinforcements already, and then I want to do beam checking, whether my section is safe or not. And then this will show us which part is safe or which part is not, with the ratio shown here. So after checking this, we can also modify the reinforcement, and then we can recheck it as well. So we have two very similar functions, design and checking, but design is the one program will recommend you the required reinforcement, and checking is the one you enter the lever first and then verify the section. So let's check a little more details for this. So for the beam design, after doing the design, I will extend this dialog box. And here we can see the two options, member, sort by member or sort by property. Section property is the one we specified from this section. So all the beam has similar section property, which has this number 10 and 11. So only two section property is there. In that case, most critical results will be shown in the report. So for example, among the section property number 11, most critical elements results can be shown from here. And their number can also be verified. But if we want to check more details for each of the member, in the case we can select this member sort by member function. After that, for example, we can check on this option in order to check where this member is located. So for this member, which is located in the second story, for this girder, you can see the design results of them. So this one-page summary for the positive and negative moment and the shear force results can be verified. And if you click this detail button, and all the calculation can be verified, including the parameter. So section size and their material property and member force, from which load combination it has been found, and the reinforcement that program recommended, and design parameter like the partial factors, and the reinforcement requirement like the minimum or maximum reinforcement requirements. And then neutral axis has been found and resistance has been considered. So all these calculation you can verify it. Same for the shear. So for the shear calculation, we can see how the resistance has been calculated as per the Eurocode formula, and then what was the member force calculated from the analysis and compare them, and then determine whether shear reinforcement is required or not, and then minimum shear reinforcement will be calculated. And after that, we can also select and enter the reinforcement from here using the Update Riva button. So after entering the reinforcement, and also we can modify the reinforcement from here. So these are the reinforcements determined from the program. And if you want, you can modify the number of reinforcements or even the size of the lever for leftmost part, center, and the rightmost part. After modifying it, we can do the checking as well. In case of the column design, it is very similar. So we do the column design, and if you see this summary report, the front part is this PM interaction. So for the column or wall, we need to consider this axial and moment interaction to calculate the resistance. So that will be considered, as you can see from this graph. Similarly, we can check their reinforcement or the detailed calculation from the report, and also the PM interaction curve can be shown from here. After that, as I mentioned, if required, we can do the concrete code checking and the wall design. For the wall, we can do the design. So I think you know we have the wall element in Midas chain. So when the wall element is used, this wall design function can be used. After checking this wall design, now we can see the results similarly. As you can see, the PM interaction, but the both direction for the major and minor axis can be verified. And similar 3D interaction is considered, and the detailed report will be also there. And we can also modify the reinforcement and do the checking. So that part is very similar. Now we want to move to this is the formula that being used in the program, so you can check it later. Or the formula is based, we took it from the Eurocode, so it must be familiar for you. And all these design results we already checked and modify the reinforcement we have checked already. And design results can also be checked from the graphical format. We can specify desired combination or the envelope combination, and then we can check their ratio from this graphical format. So which member has the exceeding the ratio 1.0, which means the not satisfied. Or for some of the element, we can also display their reinforcement. So how the reinforcement has been determined for the major lever or the shear reinforcement, it can also be displayed in this model view. So all this calculation has already verified from the graphical format, the reports, the graphical reports and the detailed report, and that is also displayed from here. And there is one more useful function which is called section for design. In the beam design, for example, we have already performed the beam design, and after that, some of the member was not satisfied. They were shown as NG. I will select the few of the elements in order to reduce the design time. For these beams, I want to perform the design. And in this case, there is elements which is shown as red color. If we see their reports, we can see it is not satisfied. And in this case, we should modify the program already tried to enter the maximum reinforcement and it was not satisfied. So in that case, we can modify the section size or the material strength. So for this element 1626, if we want to modify the section size, we should go to here and then we should modify the section size from here. It means we have to reanalyze the model and redesign everything, which takes a little time. So just for the try and error, just for checking purpose, we can use this section for design function. So for this member, I want to modify their size. For example, I want to increase the section height. After that, I want to redesign these members. So before reperforming analysis again and again, just for checking whether my section is satisfied or not, we can use this section for design function. Surely, after you determine the final section size, you have to modify this into the section size in the pre-processing for updating the member force. But just for initial checking, we can do the we can use this section for design function that will be useful. So after that, uh, sorry, let me select the section that I just modified and then let me show you. So for example, this one, its initial size was 0.6 for the height, but as you remember, I have changed the size to 0.7. And if we do the member design, and then if we check the size now, you can see the updated size is there. So instead of doing the analysis again, we can briefly check whether my change is okay or not. After that, we can finally modify it from here. So that this section for design function can be useful when you are dealing with the some of the section not satisfied and you want to recheck it. Now I want to move to the one more part. Let me show you. For the serviceability checking, like the stress, crack, and the deflection I mentioned, we can enter their allowable value from here. And then this serviceability can be verified from the concrete code check. So let me perform the beam checking for some of the member, for example, this one. After performing beam checking, then we can check the serviceability result. Here you can see the option, strength, and the service. And we can verify whether they are okay or not. So their stress or the crack and the deflection calculation can be checked from here. And let's check more details for them. So first, URS checking results will be shown first up to here, and then we can see the stress limit check. And these two values already defined by the serviceability parameter, and program calculate the stress using the neutral axis position and the moment of inertia. And then this tensile stress or the compressive stress can be calculated, and it is verified. Tensile stress is verified with the cracked stress, and then compressive stress is verified with the K1 value into the FCK. And then program will check whether it is safe or not. Also for the steel, similarly, the steel stress is calculated and then verified. Also, whether linear creep can be considered or not using the K2 factor, we can verify it. So this concrete compressive stress can be calculated and verified whether. So this model, we can use the linear creep. And when we calculate the stress, firstly, program will assume the section is uncracked. And if it is determined as cracked section because the tensile stress of the concrete is larger than the FR, which is the cracked stress, in the case, program will recalculate the moment of inertia, which is the ICR, and then all the stress will be recalculated. So for the bottom of the section and the top of the section, the same calculation will be going on for the stress. And the crack width. So crack width can be also calculated based on the Eurocode formula. So as you can see from the formula shown here, the program will calculate the cracked width, and it is compared with the allowable crack width. So finally, determine whether it is safe or not. So for the crack width for the bottom reinforcement or crack width for the top reinforcement separately, it is verified. And in case of the deflection, we can calculate the deflection value from the FEM analysis. And then it is verified, it is compared with the deflection limit value entered by the program, by the user. And then it will be determined. So these three serviceability checking is provided: stress, crack, and the deflection. In this beam element, deflection is based on the uncracked section. But for the slab, we provide the deflection for the cracked section as well. So I will show you for that parts in the slab design. In case of the beam design, at the moment we do not support the cracked deflection. It is not there for the beam. So now I want to move to the slab design part, which is using the plate element. For that, let me open another model file. I want to show you the slab design feature using this model file. So in this model, it is composed of the mat foundation, flat slab, and the meshed wall element as well. So we are going to check both. It could be confused for you because Midas Gen provides two different wall design functions. One is wall design under the here, or in the meshed design there is also wall design. Difference between two is above one is using wall element, which is suitable for the middle or high-rise building. For the wall element, as you checked from the previous model, we do not make the mesh in between the each story level. So that wall element is suitable for the mid-rise or high-rise building, like the above the 10th floor. But if you are dealing with the low-rise building like this one, in that case, we recommend you to model the walls using the plate element like this one. So in that case, how to verify, how to design them? We can use this wall design function, which is using the also Eurocode formula. So I will show you both the slab design and wall design function. For that, let me activate only the basic story. From this general procedure is very similar. So we create the load combination first using similarly from here. After that, we will move to mesh design function here. And service load combination type, it is same as the one I already explained. But here we can see the additional function. The meshed slab wall design combination. Why we have this function is all the combination we just generated. It's shown here, but depending on the country's design experience, some of the country they want to consider the only vertical loads combination for the slab design. They do not want to consider the combination with the lateral load. In that case, we can only select the desired combination, and then that will be used for the design feature. So we can select the desired combination from here. And this is also similar. So which reinforcement is going to be used for our design? And for this, as I mentioned, at the moment only GB Chinese reinforcement database is there. So in that case, we can go to the preference, design, and then if I go back to the dialog box, now we can see only the European reinforcement will be shown. So which reinforcement is going to be used for the automatic design, like their main diameter and the spacing. So for the slab or mat foundation or wall. But here above, you can see additional function, basic lever. This basic lever is useful for considering the practical design. Some of the engineer may want to consider the reinforcement for entire slab with the same reinforcement, same spacing. After that, only for the parts which are not satisfied, you want to consider the additional reinforcement for example, the column heads or the other parts. So if you want to do so, you can check on this option basic lever. So this basic lever will be entered entire part, entire area of the slab, and then additional reinforcement will be added only for the required parts. So that is the stand for the basic lever in here. And same serviceability parameter can be checked from here, like the stress, crack, and the deflection is there. And I mentioned for the slab, we provide the cracked deflection. In order to calculate the cracked deflection, we need to update the moment of inertia. That value can be calculated using this cracked analysis. So after we do the elastic analysis from here, we need the additional analysis in order to check the cracked deflection. So that cracked deflection we will also check. Now let's check one by one, starting from the flexure design results. For the flexure design results, basically Midas Gen provides the Wood-Hammer moment formula. Wood-Hammer moment formula is this one. You can also find the information from the online manual of Gen. So if you are not familiar with this Wood-Hammer formula term, you must be familiar with the design force, which converting the torsion of the slab into the two different directions of the reinforcement. So considering the torsion, we calculate the required reinforcement for the x direction and y direction. That x and y direction can be perpendicular to the global xy direction, or it can be any other direction. So how to consider that reinforcement direction? We can go to the domain. As you can see, direction 1 and 2 can be entered from here, or we can directly enter desired direction. So two reinforcement does not need to be orthogonal always. It can be any other angle between two, and then the required reinforcement will be calculated. So let's check the flexure design results. Since it has many plate elements, let me activate the certain parts and I will show you. After performing the flexure design, we can check those results. Firstly, the value of the Wood-Hammer moment, or the required reinforcement, and also we can check the required rebar area, and also the neutral axis position, the ratio between the neutral axis depth and the entire depth. This Wood-Hammer moment value is shown as the range here, or detailed value can be checked from the table format. So these three are the one obtained from the analysis, like the x, y, and xy direction torsional moment. Using this, we have calculated the Wood-Hammer moment, top and bottom reinforcement of the two different directions. And required reinforcements can be determined from here. This required reinforcement is calculated based on the elements. And you remember, I considered the basic rebar Basic lever, as I mentioned earlier, it will be applied to entire slab. After entering the basic lever, some part is satisfied with the basic lever, no more reinforcement is required, but some part we need the additional reinforcement, like the same P12, but the 100 spacing. So additional reinforcement is also shown here. So program calculates the required reinforcement. We can also update lever, and then we can do the modify or do the checking, like the flexure checking. And let's try to check the shear checking as well. Punching shear can be verified. In the program, there are two options for the punching shear. If you see, one is the stress option and the other one is force option. Force option is the one that you will be familiar with this formula, Eurocode formula. So using the column force, which will determine the VED value, and then the parameter of the critical section, and the depth, and the beta value, which is considering the unbalanced moment eccentricity. So using this, we can calculate the shear stress, and then it will be used. It will be used for the punching shear checking as per the Eurocode formula. But as Jen is performing FEM analysis, the exact value of the shear stress can be also determined for each of the position. So program can divide each part and then determine the shear stress. So this stress option is based on the FEM analysis. So stress value itself is determined by the analysis. And this is using the formula of the Eurocode. So you can use any of these two options. So if we go back, firstly, I have performed the force method. And you can see the critical parameter and their ratio. And if we want to see more detailed results, we can check it from this design results text format file. So what is the VED value, which is the obtained from the column axial force, and then critical parameter and depth, we can calculate the stress. In this case, we also need to calculate the beta value, which is considering the eccentricity, especially for the corner column or the edge column. This beta value is calculated based on the Eurocode formula, as you can see from this table taken from the Eurocode. So from here, program can determine the beta value and finally calculate the value of the punching shear stress. And their resistance will be determined and it will be compared. Concrete resistance, and it is compared whether it is OK or NG. And if required, the additional shear reinforcement will be calculated. Not only the critical parameter, but also the column phase, this punching shear verification will be performed. So that was the calculation of the punching shear. Now we want to move to the serviceability checking. For the serviceability, so stress crack and the deflection will be determined. Especially for the crack, quasi-permanent load combination will be used, and the stress characteristic combination will be used. And deflection, again, quasi-permanent combination will be used. So in order to reduce the time for performing analysis, let me check. The quasi-permanent is 36 and characteristic 22. Let's perform design for those two load combination. So characteristic 22, let's try to check the concrete stress. I have selected only that part, so that is shown. So for the activated part or for the selected elements, the concrete stress will be calculated. And just for your question, punching shear for the edge wall. At the moment, we consider only the columns. So for the punching shear of the wall, it is not considered for now. Only the column we consider the punching shear. And now stress result is displayed. So let's check their result. For example, I want to check the stress of this element, and we can select the design results text file. So for the selected element, how the stress is going to be calculated. Just like the beam element, firstly, program will assume it is the uncracked section, and then stress is going to be calculated for the concrete and the steel. And it is compared with the cracked stress or the steel stress. It was for the bottom of the section and for the top. Similarly, we assume section is uncracked and then calculate the concrete stress, and this concrete stress is compared with the cracked stress of the concrete, and it is determined as the cracked section. In the case, the dead load and live load, different load case will be used, and they are going to consider it, as you can see from here, because for the long term and the short term, different factor should be considered. That's why we have used the function long-term and short-term function you remember here. So depending on this, program determine the load case with the different value of n, and then the stress will be calculated for the concrete and the steel, for the dead load, and for the live load, concrete and steel. This n value is the one, the elastic modulus ratio between the concrete and the steel. But for the long-term dead load and the short-term loads, different n value should be used. So that's why we have classified for this stress calculation. And finally, the final concrete stress and the steel stress has been determined and compared with the allowable value. And that if they are not satisfied, and as you can see, they are shown as this not acceptable. And if we display the ratio, that part will be shown as the red color. Let's try to check the crack control now. In the Eurocode for the crack control, we can check 4 different lizards: crack width, minimum reinforcement area, river spacing, and the river diameter. Let me select the quasi permanent slot combination, and then let's try to check the crack width. If we want to consider the smoothing, we can also do that. So this is the option for the smoothing, but since the program should calculate the averaging force, it takes a little time, so I just didn't select it. But if, especially for the plates over supports or over a column, you may want to do the smoothing. In the case, this width option can be used. I didn't bring the details how the width is being calculated, but you can find the very detailed formula in the online manual how the smoothing is being determined. And that smoothing width, like the 1 meter, I want to make the smoothing or the smaller or larger, we can directly enter the dimension from here. Crack has been calculated, so let's try to check the result. So this is the crack width ratio. So all the parts are satisfied. And again, you can check more detailed results from this report format. For the selected part, which has the largest ratio, their crack minimum reinforcement area can be calculated. All of them is based on the Eurocode formula for the bottom and the top. So at the moment, we have assigned the reinforcement. So this is the reinforcement entered in this plate, and the required minimum reinforcement area in order to control the crack. That can be calculated from the formula here, and that has been determined. So whether it is satisfied or not, we can verify from here. Same for the top. So also crack width. Crack width calculation, this formula same formula used that we already checked for the beams. So first of all, we calculate the crack width from, as you can see, and then allowable crack width is calculated and they are being compared. Also, the maximum reinforcement diameter is determined, and also the maximum reinforcement spacing is determined. So all these required part as per the Eurocode is being considered in this crack width control calculation. But from your question, the nominal stress from the shrinkage, that is not being considered in the program at the moment. And if we move to the deflection, you can see 2 different options, uncracked and cracked deflection. So if we perform the cracked analysis, then we can also do the cracked deflection. So how to perform cracked analysis? It is also very simple. So we can specify the number of iteration we want to consider. Since it is the nonlinear analysis, those iteration and the convergence tolerance is required. And then the crack analysis is going to be performed. After performing the crack analysis, then we can check the crack deflection. For that, I have already performed the crack analysis in this model, which has the math foundation that we checked. So for this, I have performed the crack analysis. And after we perform the crack analysis, if you go to the folder that program is saved, crack analysis, this out file is being considered, being automatically generated for more detailed calculation value. So let me go to top of this table. For each of the iteration, for each of the elements, how the cracked moment of inertia is being calculated and where will be the neutral axis. So those detailed value can be verified for each of the calculation. And finally, the correct deflection can be checked. So for this, we can check firstly the uncorrected deflection. Let me select only the coarse permanent load combination, which is SLE1. After that, also we can check the correct deflection. Also, if required, we can consider the long-term deflection, considering the creep. Since it has some plate elements, so it takes a little time for the calculation, but finally we can check this deflection value. So with the value or ratio, we can check, or even for the correct deflection, if we want, we can also verify. Analysis result has been deleted after this. So it takes a little time, but if we perform this correct deflection calculation, and then we can verify it. Similarly, the detailed report can be viewed. So how the deflection has been determined, and for the cracked or uncracked section, and even for the long-term deflection, and whether it is satisfied with the deflection limit or not. So that was for the slab design. And as I mentioned, I also want to show you the wall design results using the plate element. So for that, we can again go to the mesh design, and this time wall design. We can check the wall design, and that is using the stress of the horizontal and vertical stress of the plate elements. And by comparing those in-plane stress with the shear stress, depending on that, we will determine the required reinforcement. This is according to the formula from the Eurocode. So we can verify the wall design results, and we can check it for the reinforcements or the resistance ratio or required reinforcement area. For the horizontal reinforcement and the vertical reinforcement separately. And for the vertical stress, same reinforcement has been determined. If we see detailed calculation results, we can also verify it from here. So stress determined from the analysis is shown, and that after the analysis stress, this each direction stress is determined, and also for controlling the crack, in order to check the safety from the crack, this sigma CD value is being calculated. That value is also can be selected from here. So whether with the crack they are safe or not, we can verify. So this wall design using the plate element is also considered. Among your questions, the compressive zone in the height of the compressive zone in the cross section. If you could give me more details for your question, I can give you the answer. Okay, so that was the main part for the RC design of the gen. And I want to move to the next part. I guess you are not performing the capacity design as your majority part. So I want to show you the steel design.
Excuse me.
Mm-hmm.
We had some questions before we go over to steel design. Is it possible to take them now? Or?
Yes, you can ask question now.
Okay. One of our main questions is the joint force between two wall elements, for example.
For the prefabricated walls.
Yeah, yes, exactly.
Yeah. For the prefabricated member, at the moment we do not have the special function for that, but if required, you can use the release function. So Piment lilies or the plate and the lilies, using those lilies function, you can model them, but there is no special function for the design.
Okay. What is this Lily's function? Can you show us?
Yep. So for example, for let me open the other model. So for the prefabricated member, their joint is not 100% rigid, like the cast in place member. So in the case, here you can see the Pimentel lilies. So we can specify their lilies with the not if you just check on and entering 0. In that case, it is totally pins connection. But if you want to consider the lilies with the partially released member, in the case you can specify the ratio in here. It's similar for the plate elements. So plate and the release can be used, but partial release is not there in that case. So only the 100% release or the rigid connection is considered. So for the connection, we recommend you to use the beam and release function between the beam and the wall connection parts.
And between two walls?
As of now, we do not have function that releasing them between the walls.
All right.
Okay.
Thank you.
And the other question was the height of the compressed zone. For the you need to know how big parts of the cross section that are compressed. Let me open any other model that already analysis has been performed. So I guess that compressive height will be verified with this x by d ratio. D is the entire length of the section, and then x is the neutral axis position. So using this ratio, you can verify the section. Okay. So now I want to move to I will just jump the capacity design. Just for briefly saying, if you want to do capacity design, you can check on this option, select the doctorate class, and then program will do all the member force calculation based on the strong column weak beam or strong shear weak flexure moments rule. So all these member force will be differently calculated. And let's check now the steel cost checking. For the steel cost checking, also let me open another model, steel structure. And in this model file, Steel code checking is also quite similar. And as per the Eurocode, which section can be verified and what is calculated? We can check from this table. So I-shape section, box, angle, channel, T, double angle, and the double channel, pipe, solid rectangle, solid round, U-leaf. As you can see, U-leaf is not supported, but the above one can be verified as per the Eurocode. Mainly, we provide the yielding and the flexure buckling. And shear buckling, as you can see from this V mark, which one is being calculated. And the lateral torsional buckling at the moment, I section, doubly symmetric section is supported because of the calculation of the buckling curve, which is provided in the code for the doubly symmetric I section only. So based on this table, we provide the section checking, and this shows all the calculation procedure as per the Eurocode. So program will consider the section classification. After that, resistance will be calculated for the compression, tension, flexure, and the shear, including the shear buckling, and the combined, like the bending and shear, bending and axial, and bending, shear, and axial combined one. For the buckling resistance, so similar. We check the buckling resistance under the compression and buckling under the bending, and also lateral torsional buckling. So let's check with the program. So we select the desired code again. We are going to steel. So select the desired code from here. Okay, and then I'm going to do the steel code check. Since it takes a little time, so let me select only desired part of the element, and then let's briefly check the results. For these members, so we can check the graphical reports, detailed reports. In the graphing reports, so firstly, slenderness ratio is checked, and then axial resistance, bending, combined resistance, and shear resistance, deflection. Also, we want to see more detailed calculation. Firstly, the section parameter and member-related parameter like the embraced length or the effective length factor that I explained at the beginning, and the member force from the most critical load combination, and section classification. So section has been classified as class 1. And then now we calculate the resistance starting from the axial. So axial resistance is being calculated, and it is compared with the axial member force. Similarly for the buckling, axial buckling resistance and the axial member force compared. For the shear, we calculate the shear resistance, and then compared with the shear member force. And we also verify the shear buckling. First of all, as per the Eurocode, we verify whether it is required to check or not. If not required, we just skip it. Shear is verified for both direction, major and minor direction for the beam element. And for the flex shear, we calculate the moment resistance, and it is also compared with the moment member force. For the positive moment and negative moment, we check both. And lateral torsional buckling. So correct moment is being calculated. And in this member, lateral torsional buckling is not required to check. So it has been finished, as you can see from here. Finally, the combined resistance. So combined resistance of the bending and axial and combined resistance of the entire this part is required for the bending and axial compression member, and both bending forces are calculated, and it is required for the buckling, actually buckling combined force. So all of this calculation, as you can see, very detailed described, so you can verify easily from using this report. Finally, deflection. Deflection is same. Program calculate the deflection value, exact deflection value from the FEM analysis, and it is compared with the deflection limit value entered in the serviceability parameter by the user. So that was the steel checking. I mentioned Midas Gen also provides the steel optimal design. So I want to show you the steel optimal design as well. In order to perform the steel optimal design, firstly, the initial member verification is required. So let's check. Program is verifying the initial member resistance. And then the optimal design can be performed with the number of iterations we will specify. In the section, we can enter the various conditions in the optimal design, like the which ratio we want to check. We want to have, like the whether we just want to have the ratio less than 1, or I want to have the more safe section, like the ratio less than 0.9 or even lesser. And the section database, from which database I want to find the section. And among the, for example, unit section, the height of the section or the width of the section, I want to limit their size, their dimension. So let's say if I enter the 0.4, in that case, in the 0.4 meter, plus minus 5% of the section size will be only found. But if I enter just a 0, the program will find entire dimension of the specified database. So we can specify the various condition from this dialog box. So it has been calculated. In order to reduce the time, I will just repeat the one time for the optimization. You can select the desired section database or shape and number of iteration. So optimal design is going to be performed, and we are going to check how the section will be changed. So program will re-perform the design. For the still design, so in your question, whether the all four section class can be checked. Yes, we support the section class up to 4. So after it is classified, then only the effective section area is going to be used. And the other question, whether you can design the section, some general shape of the section. The section design that I showed you is only for the database section. Not only the database, but the section size that is using those list. So we can even enter the size in here, but for example, some irregular shape of the section that cannot be designed inside of Gen. In the case, we have another tool, GSD, that I will also show you in the next step. So using GSD, General Section Designer, we can design some irregular shape of the section for the steel or the concrete, or even the composite section. Okay, so optimal design has been performed. So as you can see, this red color showing the original section and the green color showing the after the optimal design. So how their weight ratio has been reduced. And the weight sum of each of these section property and the average ratio as the section size has been smaller. So their ratio is now becoming more closer to 1.0. So these results can be obtained after the optimal design. And I want to show you GSD that I just mentioned, General Section Designer. In this model, all the member has the section side shape the rectangular, but in this corner column, I want to have the different shape of the section, some irregular shape of the section. In the case, I can go to Tools and the GSD. I will modify the grid size. And then we can generate the shape using this database section, or I can define the section from my own. And we can also enter the material property for this. So this irregular shape of the section has been defined, and I want to use this section for my global analysis. So for that purpose, I can calculate the section property from here, and then I can bring it to my gen model. I will just save it with the test.sec file. So it has been saved. And now I can go to the section property. I will add the new general section. So this shape is being shown. Okay. Now I want to assign that section to this column. So you can see the section has been changed. After that, I want to do the global analysis. And this member force has been calculated. As I mentioned in the RC design, we only support the automatic design for the rectangular shape or the T shape and the round. But for this column, we cannot do the automatic design in Gen. So I can bring it to GSD. I can make the link between Gen and GSD. And for this member, I can import. I will consider all the load combination for my irregular section design. So as you can see, this TT section has been imported from Gen. This load combination, this member force has been imported from Gen with this shape. Now I want to enter the reinforcements by selecting the parameter. After that, I can do the section checking. So for each of the combination that we imported from Gen, that can be shown as you can see. So from this PM interaction, whether the section is safe or not, I can check from this 2D PM interaction curve or the top view of the 3D PM interaction, which is the MY and MZ curve. And even the 3D interaction. For each of the combination, we can see their ratio, whether my section is safe or not. So as you can see, all the load combination has been determined as the safe. So we can verify the section using this general section designer function. It provides the additional option like the moment curvature can be calculated, and it will generate the idealized curve which can be used for the pushover hinge curve. And also stress contour can be verified for each of the load combination with the neutral axis position at the ultimate strength. For the mesh line, how the mesh has been generated to this GSD performs the section analysis instead of using the formula from the code. Even though it has code, only the partial factor will be used, but it will perform the section analysis. So from this mesh line, the section resistance will be calculated.
Can you add stirrups and check rear as well?
It only provides the axial and bending force check. We do not support the shear force checking in GSD. Okay. So this is the function for the GSD. Finally, I want to show you the additional design module, which is called Design Plus that I mentioned at the beginning. For that, I will use this model file. This model has the this T-shape foundation and also the walls. So which has this channel shape wall. So I will show you how we can design them using Design Plus. This is the Design Plus program. Design Plus, we can select the desired code like the Eurocode here. And also reinforcement can be selected for the desired one. And there are additional options for the design. After that, at the moment, we have the only few modules for the Eurocode, but as I showed you at the beginning, it is being implemented more and more. At the moment, we have the general section, general column checking, and the combined wall design, strap foundation. And in January, we will have the isolated footing and also the board connection. And more functions are being implemented in the 2016. I will show you the strap footing. For that, firstly, I can make the link between the GSD and GEN. And after that, I can select the desired member from here. For example, I will select these members, the strap footing. And then it will be shown here in the list. As they are connected to each other, the program can list the member and it will be imported. So the imported member can be shown from this list, and the size of the member and also the member force is being imported for the moment, shear, and the swirl reaction. After that, we can verify the section whether they are safe or not. If they are not safe, we can also modify our input. So we can try to modify the section size, or we can try to modify the reinforcement. As you can see. So after that, we can verify whether they are now safe or not. And good thing is after we verify this, and then detailed report or summary report, input report will be obtained in the MS Word format. For example, for the detailed report, it is being generated. And all the calculation procedure, just like the detailed report we checked from Jen, all those parameters and the section size, member force, and how the resistance being calculated, all of them can be verified from the Word format reports. And here you can see the several tabs at the top. So after member checking, we can see also the cross-section drawing or the quantity as well.
Sorry,
Mhm.
can you add also a pre-stressed bar in this section?
No, tendon is not supported. Only the reinforcement is considered at the moment.
Okay, okay. Thank you.
Okay, so this is the report. So for the positive bending or the negative bending, shear reinforcements or this flange part and soil bearing capacity. So this detailed calculation you can verify how the program calculates and whether it meets your requirements or not. There was one question previously for the optimal design, still optimal design, whether you can do the optimal design for the deformation. For that purpose, Midas Gen provides the optimal design function as well for the serviceability checking. So that is supported with the another function. So maybe I can send you the tutorial for that after the session. And only the soil bearing capacity is being considered, but it's so the size of the foundation should be determined by the user, and then it will just verify whether it is safe or not with the soil bearing capacity. And that value, soil bearing capacity value, is also defined by the user. After checking that, also if we move to the drawing tab, now we can see the drawing and also the quantity table for each of the parts, like the I, middle J, and their reinforcement, strap, and then concrete, and also the formwork, and quantity by the unit length as well. So this quantity table will be also useful.
Excuse me.
Mm-hmm.
Going back to pre-stressed elements, can you design any kind of pre-stressed elements in Midas, like hollow core slabs and pre-stressed slabs?
Not in Gen or Design Plus. Only pre-stress. We have the pre-stress member design in Midas Civil, which is the bridge software. But for the building software, no, at the moment we do not have. Sorry.
Okay, so you cannot model like a building with hollow core slabs or
We can,
pre-stressed.
yeah, model and analysis is possible, but automatic design is not possible. So we have the tendon. So tendon is entered only the beam element, but if you want to do the pre-stressed slab, you can model the dummy beam and then enter the slab, enter the tendon into the dummy beam, which is crossing the plate. It is not the, it's kind of the alternative way, but there will be no problem in up to the analysis. But automatic design at the moment, not possible.
Okay. All right. Thank you.
Okay.
And I have another question, if
Mhm.
it's possible. Can you show us an example with a web opening in a steel beam, if it's possible?
That is only available for the American standard at the moment.
Okay.
Web opening, we are planning to implement for the Eurocode in the near future, but not at the moment.
Okay.
Mhm.
Thank you.
Okay, thank you. Let me move to the combined wall design. I will select the code again. And I want to show you the wall design in Design Plus. As I mentioned, in Gen, we can do the wall design, but each of the unit, like this wall, this wall, this wall, they will be separately designed, which is not the that desired for the engineers. We want to design the wall, this wall, as one member. For the purpose, we can use Design Plus. So in the Design Plus again, I will make the link and then I can select the members and it imported. So it is being imported for the bottom and the top. Since the member force in the bottom and the top is different, so we have two different lists here. And each member, their member number and the wall ID is shown here. And using this data, we can verify with the PM interaction whether this wall is safe or not. So using each of the elements, they have the member force. So we calculate the wall combined force and then calculate the resistance. It will be compared. In order to check the report more quickly, we can move to this simple mode. Previously, it was project mode, which can be linked with Gen, but in the simple mode, after checking, we can just to see the calculation results briefly in the right part. From each of the unit wall, how their force has been determined for each load combination. And finally, the combined member force is determined. And for the wall, their slenderness ratio has been determined for the moment magnification. And then moment resistance is calculated and verified with the moment member force. In this case, the PM interaction is being used. For the shear capacity also, similarly, we calculate the shear resistance of the concrete and then if required, the shear reinforcement is being calculated and it is compared with the shear member force. Shear design is being performed for each of the unit walls separately. And from here, so you can see this for the moment magnification, second order effects can be considered. And this is the force imported from Midas Gen. So after doing this wall design, Similarly, we can draw their cross-section from this. As you can see, reinforcement information is also there, and the quantity table can be obtained. For the irregular column, it is also similar, but for this one, let me show you just the function without the link of gen. So calculation is quite similar to war, and different part is we can draw any general shape of the section. It can be modified with the nodal coordination, or you can import the AutoCAD file or the Midas SEC file, which can be generated from the GSD or SPC, the tool for generating the irregular shape section. And then reinforcements can be specified and it can be verified. So that was the function for Design Plus. If you have any other question, please let me know.
Excuse me.
Mm-hmm.
We have a question about imperfection calculations.
Imperfection. Imperfection is not considered in Gen at the moment. So for considering the imperfection, we should enter the notional loading separately, manually. We are planning to implement it in the very near future, but at the moment it's not possible.
Okay, and this was for the global imperfection, right?
Yep. Local imperfection, yes, it is being considered in the design.
Yeah, that was actually my question.
Okay.
Um, is it possible to maybe show how you implement it, or is it a quick?
You mean the imperfection, how it is being implemented?
Yes, the global one.
You mean global?
Yes, global, yes.
You mean manually how to consider it?
Yeah, how do you?
Actually, for that, I can give you the one document which is explaining the manual consideration how we can do it with Gen. So for the global imperfection with the different load combination, we should calculate this notional additional loading. So it means we should enter the additional loading manually after calculating the required value of the loading. So as per the Eurocode, I will send you these documents to you right after the session.
All right. Thank you.
Okay. So that was the all I prepared for the today's session. We finished it Design Plus and the GST all the parts. So any question if you have more, please feel free to let me know.
Will we get a copy of this presentations, PDF and PowerPoint presentations?
Yes, yes. So I will
Okay.
send you. Also, do you want to have the model or is it okay?
Yeah, yes, please.
Okay. So model and the presentation I will send you.
Mhm. And if we have any further questions, can we contact you personally or?
Oh, yes. You can contact. Actually, I'm also one of the person who received the e-support, or if you want, you can send email to my email address,
Okay.
HYLEE.
Excuse me?
I wrote in the chat box. Can you see HYLEE at midasit.com?
Yeah.
Uh-huh.
Mhm.
So you can send email to this mail address or e-support. Both of them, I will check.
Okay. Thank you.
Okay. So any other question?
Thank you very much for your presentation.
Thank you very much for your attention for such a long time. I will send you all the information materials after that. Also including the recording just in case. I recorded this session so you can check it later.
Okay,
Okay,
that's
thank
great.
you.
Thank you.
Okay. Thank you very much. Have a nice day.
Yes, same to you. Bye-bye.
Bye.
Bye.